So we're better than the next guys because automation and process control. Some of the things that we do, we don't just do high volume production. Actually, what we like to think of ourselves as a medium volume manufacturer, high complexity and low mix. That's what the ideal situation is. But there are times when the best scenario for us is a very complex part in even low volume. And in this case, what we're looking at here, we're looking at metal optics for the defense industry. These happen to be mirrors that are for Lockheed Martin, and they're 6061 T6 aluminum, but they go through several different processes where we get close to the finished product and we send them out and have them thermal cycled for stability purposes. Then we'll physically lap the parts on a lapping table, and then we load the parts back in the machine, and on that perfectly flat surface we go and do all the finishing cuts. We're able to do things that other companies aren't in terms of our ability to really make a higher quality part and hold closer tolerances. And again, it goes back to our process-driven business, and even putting in lapping cycles into the process. We're not just loading a hunk of material on the machine, pushing the button and hoping we're making good parts. We're driving the quality through the process, we're building the quality into the parts. One of the things that we're very good at is making hog-outs, okay? Taking a part that might otherwise have been a cast part and figuring out how to make that part more effectively and make a better quality part. And sometimes that's thinking outside of the box. So what we've done with this particular customer is we've actually taken a part that was previously cast. They were purchasing the castings out of this country. This happens to be a defense part. So they were looking to have 100% US sourcing, and rather than going out and tooling up a casting supplier and paying all the money for casting tooling and dealing with porosity and all the issues related to castings, we came up with the idea for this particular job where we actually designed and built an extrusion. So you see the extrusion here, okay? Ultimately, this is the part that we're building. Okay, so we're just getting set up on this. This is our setup piece. But you can see that out of this, out of the extrusion comes the finished part. And you can see how efficient that is. Very little raw material to cut. You've got some angles that are already extruded into the shape. This is a very efficient process. It's going to be extremely repeatable. The part quality is going to be much better than a casting, and the cost will be lower ultimately. The machine, and they're ready to go to the next step. What we're looking at here, for example, these are thermal weapon sight housings for a weapon-mounted camera. But you notice how we use these cap plugs in our parts, and what we're doing here is we're just protecting them from damage. All the way around, it's all about driving quality and having a process. And this part here has a very complicated O-ring groove, and it's critical to our customer that that O-ring groove arrive without any damage. So we protect that O-ring groove by just taking a simple cap plug and putting it on the part. This is another interesting part. This is a secondary muzzle reference sensor that goes on a 155 millimeter howitzer way out on the end and sees some pretty significant heat and so forth. But this is a very complicated, very close tolerance stainless steel machine casting, and what this thing does is essentially make sure that the the round from that cannon ends up in the right place, compensating for coefficient of thermal expansion over the long length of the barrel of that gun after multiple rounds. So it's there's one of these on every tank. This is an example of a cast machine component that we're doing. This is for a system called IBAS, which stands for Improved Bradley Acquisition System. That's a targeting system, a cooled thermal camera on a Bradley fighting vehicle. So these parts here, this is a legacy part that Hoppe Tool has been building for about a dozen years, I'll say. And essentially this is a rocket motor that tows a line of grenades in the battlefield for anti-personnel obstacle breaching. So landmines, fences, and that sort of thing. This is essential to the Marine Corps troop safety. But we deliver these full up, assembled, painted, obviously without the explosive material inside of them. In addition to being a CNC machining house, we also do full up assemblies or sub-assemblies. So in this case, we're building up a vehicle mount that will have a pan and tilt device with a thermal camera and a thermal imager that goes onto a Humvee. But you come in here at any given day of the week and we may be building something entirely different. Now this is a fairly good size assembly. Some of the assemblies that we manufacture are relatively small. Here's a case where this is a sub-assembly of another assembly that we manufacture for the customer, but it just simply has an aluminum part with a couple of bronze rollers in place. Part marking. Again, we do a quality part marking job. In this case, this is an ink stamp. These are some small sub-assemblies. This is what's referred to as a rail grabber or a weapon mount, and this allows the soldier to be able to slide this weapon mount with a thermal imager like those housings that you saw onto his weapon, and then set the torque is preset so that when you turn this over, it snaps into place, and the torque setting is always the same on these things. So anyway, we're building these, by the thousands, as you can see here. This is an example of a finished assembly that's ready to go out the door to our customer, and this is kind of an interesting part. This is what they call a reaction wheel for a satellite, and anything that goes up into space, of course, everybody's very hypersensitive about, because the part quality is essential, and our customer has chosen us as a sole source on these parts because they've grown to trust our inherent quality in all of our processes, and the finished component parts not only look great, but they are dimensionally 100% correct. There is no deviation capability on space hardware.